This is question 7 of the 2019 higher level Leaving Cert paper. As you can see on the screen, it's split into two parts, A and B. I'll be jotting down the relevant details for each part and attempting to solve it. If you don't have the question in front of you yourself, you can pause the video here and take down the information, or you can find in the comments below a link to the image, as well as a link to a page where you can get the entire exam question. Okay, here's the relevant details from part A, or at least the parts I found relevant, which might not be the same thing, I admit. They've drawn this trough for you, basically something you feed an animal in. So this is hollow, you would pour water or food into this and an animal could eat out of it. And then they've drawn the same shape if you look in at the side. So here's A, B, C, A, B, C. This is the same shape. This is just to give us a better understanding. So we'll be able to get the lengths and angles from this. Now, one thing I sometimes tend to do, and I know other students do, they jump right in and start to fill in some numbers here. That can be good, but one thing I'd say is the exam tends to ask you the questions in a good order. So the first question they ask you is AD. So often, that's a good way to start. And then they'll ask you something harder, something harder. But if you do like to just jump in and fill in any numbers you think here, solve the problem and fill in every number, it can be a good way to do it. And then once you ask the questions, you have all the answers. But let me do it in order myself. Okay, so part 1, they ask us the length of A to D. Now, to do that, I would jot down this triangle. I take this triangle out here. And for any triangle, I'm always looking for 3 pieces of information. That's enough information for me to solve anything I want, basically. So I see 90 centimeters here, and I see a right angle. That's 2 pieces of information. I know a length and I know an angle. So I need something more. This is the length they're asking for. I need either this length or one of these angles. And I can see what this length is here, because they tell me that this is made by a circle starting at O. So that means this is a radius 90, this is a radius 90, and O all the way down to B is also a radius of 90. But they also tell me this part here is 30 centimeters, which means what's left all over must be 60 centimeters. So now I have 3 pieces of information. So I'll just go ahead and find this length using Pythagoras' theorem. So Pythagoras' theorem tells me 90 squared is equal to 60 squared. Oh, not 60 degrees, 60 squared plus this side here. Let's call it something, just so it'll make the maths easier. Let's call it x. So plus x squared. Let's just rearrange this and solve for x. X squared is equal to 90 squared, and take 60 from both sides, minus 60 squared. X is equal to 90 squared minus 60 squared and the square root of that. Now at this point we could just put this into a calculator. And luckily for a lot of students, the calculator will give you the answer in the form they asked, because they did ask us in a certain form. They asked us A multiplied by the square root of B, where A and B are integers. Now calculators nowadays does do that for you, so you're probably saved a little bit of work. But let me pretend you don't have a calculator, because hopefully sometimes the exam will be smart enough to say no calculators on this question. So, and certainly in the Irish system they don't at the moment, but I know they do in the Cambridge International system. So let me go through it anyway. So x is equal to 90 squared minus 60 squared. Well, that's 81 minus 36, which is 45, and they're both multiplied by 100. So 4,500 square root of that. Another mistake this question is actually made is this is already an answer. If you just put a 1 there, they just asked for 2 integers. 1 and 4,500 is an integer, but they really want to get this number to be the smallest you can make it. They didn't say that though, they really should have, but they didn't say that. So let's do how the question probably should be done. X is equal to, let's split this into 2 square roots. And one of those square roots, let's make it a perfect square. So I can see 100 goes into this number, and 100, the square root of 100 is 10. So that's a good number to take out. And this will be 45. So that is equal to 10 multiplied by the square root of 45. Again, technically this would be correct the way they phrased the question, but that's not what they wanted. They did want us to do a little more. Is equal to 10. We can again split up the square root of 5 into two things. Square root of 9 and square root of 5. And that will equal 10 times the square root of 9 is 3. So 10 times 3 is 30. Multiplied by the square root of 5. That's the final answer that they were looking for. This is, I guess this is still in centimeters. That's going to be important because I can see that this is in meters, this is in centimeters, and yes, some of the later questions do ask for it in meters squared. So that's going to be a problem in the future. For now, let's remember it's in centimeters. And we'll go ahead and write it down on our picture that I'll rub this out so I can do part 2, but I'll keep the information here, 30 square root 5, and it's in centimeters. We'll try and remember. What else did we find? We found out that that's 60. Okay. Yeah, I'll rub this out and we'll start part 2. Part 2 asks us to find this angle, DOA. Let's check where that is. It's DOA. So it's this angle in here they're looking for. Let me just put a little arch there. Well, let me draw the triangle again, I guess. DOA. They're asking us to find this angle in here. Let's call it theta. And remember, we know 30 square root 5 here. We know 60 is here. We know 90, and we know we know it's not square root, it's a right angle. So we know 4 things about this triangle, more than enough. 3 things is enough, unless it's all 3 sides. So there's a few formulas, cosine formula, sine formula, tan. We'll all find this, but I'll go ahead and use the cosine. Cosine theta must equal the adjacent divided by the hypotenuse. So however you remember that, I can't remember any of the mnemonics that you learned to do it. Oh, it's just come to me. So how I remembered it was, I always remember sine, then cosine is next, because it's after sine, then tan is next. So I just remember them, and then it's another hour of algebra. So they're all equal there. And I guess I need some thetas. Anyway, that's how I remember it. Well, actually, nowadays, how I remember it, I just remember them. I've done them so much for so many years. I just remember them all. But you don't actually have to. You're usually given a formula book that will have it in it. So cosine theta is equal to the adjacent over the hypotenuse, which means theta is equal, that's equal to 2 over 3, first of all. So theta is equal to the inverse cosine of 2 over 3. That's a perfect answer. They wanted the answer to the nearest 2 decimal places, which we'll take a calculator to do. One thing to be careful of, they asked for the answer in radians, not in degrees. So make sure your calculator is set to radians before you do this. So the inverse cosine of 2 divided by 3 is equal to 0.84 to 2 decimal places. So I'm not sure what the answer would come out as, probably about 40 degrees, something like that, between 30 and 50 anyway. So just be careful that you do not give them in degrees when they ask for it specifically in radians. So let's put that in here. Let's 0.84. That's the angle of that. Okay, I'll rub this out and we'll do part 3. Part 3 asks for the area of ABC. That's this small shape down here. I'm going to draw these shapes because I just find it easier to explain it this way. They ask for the area of this. Now, I don't have any formula for what this is, just to draw it again. What this is, it's part of a circle. I don't necessarily, there probably is a formula out there, but I don't have it on hand. It's not in my tables. So how do I get this? Well, this is how I get it. I get part of a circle. That's easy to get. It's just a circle, pi r squared, and whatever percent of it. And we have a couple of formulas for that, so we can get that. We can get a triangle. If we take that away from this, it should equal this. So that's what I'm going to do. So let's try and split this question into 3 parts. Will I squeeze this in? I'll try my best. So the area of a part of a circle, when we're dealing with radians, it's just the angle of this divided by the total angle, which is 2 pi. All the angles in a circle is 2 pi when we're dealing with radians. So the angle in here divided by 2 pi multiplied by pi r squared. So the pi's cancel, and we're just actually left with 1 over 2 angle. Oh, that's a different angle than I used before. Let's use this angle here. Let's use phi. A half the angle multiplied by r squared. That's the area of this. The area of this guy is equal to half the base by the height. I'll just use b and h for now. Okay, so I just need to fill these out. A is equal to a half this angle. Be a little careful. They asked us to find this angle. We actually want 2 times it. So we want 2 times 0.84. You should be a little careful when using rounded numbers. I think I would rather use an exact number here. Although I do believe the question works out fine. I find it unlikely they would have given us numbers that wouldn't work. They asked us to round that off to 2 decimal places. I assume it's enough to make our final answer 2 decimal places. But it seems a little dangerous to me. So I would rather use the inverse cosine 2 over 3. We can just put that in a calculator again and use the exact answer. This is the exact answer. And then r squared. Again, we need to be careful here. R is 90, but they would like meters in their answer. I'm afraid I'm going to have to make a bit more room than this. Let's just do it like, let's move everything over a little bit. So we have minus, we'll get a triangle here, and we equals. We don't need any room for the equals. Equals this segment. And we'll rub out this part. Okay, so we have 0.9 squared. So this is instead of 90 squared. So be very careful. If they want the answer in meters, use meters. You could use centimeters, but then change at the end. I find it's easier to change at the start. It's easier to change centimeters into meters than it is centimeters squared into meters squared. Alright, so to do this out, we'll just put it in a calculator, although we can note that that cancels that. I'll grab a calculator here, and we get the inverse cosine of 2 divided by 3 multiplied by 0.9 squared. And the answer comes out at 0.68 and 1. I'll use 3 decimal places myself until I get to the final answer. Or usually I just save this in my calculator and use this exact answer. So we'll move on to the circle. The area of a circle is equal half the base by the height. I wrote that out, which is equal to a half. What is the base of this triangle? It is 2 times this guy. So it's 2 times 30 square root of 5. Again, we need to be careful. This is centimeters. Need to turn it into meters. Divide by 100. So 2 times it, I got this plus this. So the entire bottom of the circle, they're both the same. It's a right angle. It's an isosceles triangle. They are both the same length. And half the base by the height. The height is 60. But again, 0.6 I think we'll use. I guess here I can use 0.3. Anyway, the calculator will sort all of this out for me. I'll just take, I'll leave this in my calculator, and I will take away all of this. That is 30 multiplied by the square root of 5 multiplied by 0.6. Oh, I'm still inside the square root. Square root of 5 multiplied by 0.6 divided by 100. And I used a couple of brackets to make sure the calculator didn't screw me over. So, damn it, I've done the entire answer, haven't I? The entire answer is 0.28. Just to help you guys, if you did these separately, and to help the examiner, let's do this again. We'll get the number here instead of the full answer. So I'll do this again. 30 multiplied by the square root of 5 divided by 100. I just put equals each time. I think it makes it a little cleaner. Multiplied by 0.6. And that answer is 0.402. So if we take this away from this, we get 0.28. This is rounded off, by the way. So that's the final answer for part 3. Let me again rub this out and we'll do part 4. It's quite short. So part 4 is asking us to find the volume of this entire shape here. And that's quite easy to do because we have the area of this cross section here. The area of ABC is equal to, we had it here on the board, it's 0.28. So to get the volume of this entire thing, the volume is simply equal to 2.5 multiplied by 0.28, which is equal to, with the help of a calculator, 0.7. Okay, so that's all 4 parts of that question answered. I'll put the entire question back up on the screen so we can have a look at part B before we do that. So here's the question again. Part B is made up of itself 2 parts, and it's all about that egg timer there. I'll jot down hopefully all the relevant details on the board and we'll see what we can solve. So here's my attempt to draw the shapes they've given us. Hopefully it's accurate enough for us to work with, and that's really all we need in maths, just accurate enough that we can follow along. And here's all the numbers here of this shape. So this shape is an egg timer, something filled with sand. When you flip it over, the sand all falls through and we get a time measurement out of it. But what they've told us is this top half here is full of sand. And they're asking us how much sand is there. So really what they're asking us is how much volume is in these 3 shapes. So they're asking us how much volume is in a hemisphere. That's a terrible drawing, but a hemisphere plus a cylinder plus a cone. So let me my attempt to draw all those anyway. So that's really what it's asking us. So we can jot all that down hopefully. The volume of a hemisphere is half of a sphere. So it's a half 4/3 pi r cubed. And then the volume of a cylinder's volume is a circle multiplied by its height. So it's pi r squared h. And then the volume of a cone. All of these volumes should be in a formula tables for you. The volume of a cone is a cylinder, but it's just 1/3 of it. The same as a cylinder, but it's 1/3 of it. Okay, so let's try and do this. Let's fill in everything. The only thing we need to fill in is R's and H's. By the way, these are different R's. No, all the R's are the same. They're all 1.25 for the hemisphere, all the way around. The cylinder, 1.25. The cone, 1.25. The H's, though, are different. So let's acknowledge that, 1 and 2, just to be fully clear. Right, so let's fill this in. We get 4/6 pi 1.25 cubed plus pi. I'm doing this, by the way, because we could do it all in the calculator. I'm doing this all the way just to show the examiner exactly what I'm putting in. I need to show the examiner that I put the right numbers into the right places, because that will get you lots of marks if you make a mistake in your calculator. If you use the calculator correctly, you're fine, but we all make mistakes from time to time. So plus 1/3 pi, or this is 1.25 again, and the height of the cone is 1.5. Okay, so you've shown the examiner all your work. Now you can go ahead and put it in a calculator. Although I will say, I'd like to take pi out of all of them. I should write another line for this, by the way, but I'd run out of ink. Just take pi out. I like to leave pi in my final answer. They often tend to ask you to leave in terms of pi, but this time no, they've asked us in 2 decimal places. So you don't have to do this, but it's a good habit, and it's actually going to help for part 2. Okay, so I'll do this all in the calculator. The calculator for all of this gives us 7.55208 pi, which is, if we multiply that by pi, multiplied by pi is equal to 23.73, I guess, to 2. Did they ask for 2 decimals? Yes, 2 decimal places. So that's our full answer. You know what, for part 2, we'll probably make do with the volume being equal to 23.73. We're not going to need to round it off any more than that, so we should keep all the information we need. But let's get to the meat of the question. The question is, there's sand in this top part of this egg timer. and then it's fallen down. 98% of it has fallen into the bottom part, leaving us 2% up here. And that's what this picture draws. They tell us that this is flat. Now that's important because real life, I think this would be more conical inwards, which would be a much harder question. But a question, if they model it exactly like a cone, they could ask that in an exam. That would be an interesting shape of a question, actually. But anyway, for now, we're left with this perfect cone inside this bigger cone. And this smaller cone, we know how much sand is there. That smaller cone that is equal, this is a volume total maybe. So this volume here, this 1 over 3 pi r squared h is equal to 2%, 0.02 of 23.73. We know this. This gives us an equation. Most students are like, okay, this is how I solved it. There's one problem. We don't know enough about it. There's r and h unknown. We don't know what r is. We don't know what h is. But this is the first half of this question. This is how we started. The second bit we need a second equation. We need more information about this. And that information comes from this cone and this larger cone. The relationship between them. We need to notice that they are similar cones. Or more importantly, the triangles inside them. So if we made a triangle here from that point and this point across, it would look like this. The larger triangle would look like 1.25 over 1.5. And the smaller triangle would be r and h. But these are similar. They have the same angles. They have all the same angles. Right angle, because they're inside this one fits inside this one. It would have to have the same. This would fit right in here. Everything has to be the same. And similar triangles, that tells us a lot. That tells us that these ratios are the same. R divided by h, or h divided by r, whichever you want really. R divided, I know this is going to work out a little neater. R divided by h will equal this r divided by this h. So will equal 1.25 divided by 1.3. That's a second piece of information. We have two equations, two unknowns. This is something we can, this is a simultaneous equation. Not a simple one, it's very messy given all the decimal places, but one we can certainly do. Okay, so let's clean this up. So we have r is equal 1.25 over 1.5 h. We can put this information into this equation here. So this information into this one here, and let's write that out. That's 1 over 3 pi r squared. R becomes 1.25 over 1.5 squared. H squared is h squared. So r squared becomes this number squared and h squared multiplied by another h. 3 h's. I could break that into, write as many lines you need. I'm just going to skip 1 or 2 here. And all of that is equal to 0.02 multiplied by 23.73. You could go ahead and use calculators each line. Sorry, this is a square I'm missing. I think I missed the square in the last part. I caught in the calculator, but I never corrected on the video. My apologies. So you could go ahead and do this each line on calculators. I like to use a calculator once. I don't like using it lots of times. So let me rearrange this. This becomes h cubed is equal 0.02 multiplied by 23.73 and divided by, let's divide across here. What do we have? We'll have things multiplying and dividing. So let's continue. The 3, multiply both sides by 3, that'll come here. And multiply both sides by 1.5 squared, that'll come over here. Divide both sides by pi, we'll have a pi there. Divide both sides by 1.25 squared, 1.25 squared. We get this. Let's just put that in a calculator. Let's find out what h cubed is equal. That comes out, according to my calculator, at least at 0.6526. Now you need to take at least 4 decimal places if you're going to write this out. Personally, I don't like to take any. I like to hold everything. Keep it in the calculator and then get the cube root of it. H cubed to the power of 1 over 3 is equal to whatever you have on the calculator. Well, it's equal to h anyway. Whatever you have in the calculator to the power of 1 over 3. So let me just put that in. To the power of 1 divided by 3. Calculators can do that. And that answer comes out at 0.8674. So 0.87 would be to the nearest 2 decimal places, which, yes, they wanted to the nearest 2 decimal places. So that's the final answer. That's the answer for this height here, h. The real trick here, most students would have got stuck at this line. They seen the volume, they seen 2%, maybe they got 98%, but they got some number here. They needed one more equation. There was one more piece of information and all of that. And that was this similar triangle. And I'd love you to remember this, because I don't think a Leave a Cert goes by without this trick being used somewhere in it. It's a favourite for examiners. They like to leave that little trick to get this extra equation in a question. Okay, so that's question 7. Tune in next video and we'll try to do question 8.